Okay, I'm just going to copy this. Okay. So based on our transformation, I'll sketch our transformation out. This is Y. This is X. Over here, this will be your Z. Okay. So now I'm going to look at our structure from the front. Okay, from the front. So now we are seeing this. So this is Y. This is Z. And over here is rotation about X. Okay. Right. Then we're going to draw the shaft. Okay, so this is our shaft. Right? And this is our center point. Okay. So now, which part of the shaft are we going to analyze? I repeat again, which part of the shaft are we going to analyze? Okay, so we're going to have 4 points. So this is my element. Okay, this is my element A. Over here, element B, element C, and then over here is our element D. Okay, so we are going to create a table, right? Okay, so if we look at how the structure is bent, right? So the structure will be bending this way, as you can see, due to the moment of 1,500 pound-feet. So at the bottom end, this will be at compression. And the top end will be at what? Tensile. Yes or no? Right? So if you ask me, Eugene, can you sketch where element A is? So element A is over here. Right? Element B is over here. Right? So this will be my element A. This will be my element what? B. And C and D, one's at the bottom, the other one is at the other end. Okay, I hope you all can visualize this. Okay, so now we are going to look at element A. Okay, we're going to create a table. Element A, element B, element C, and you have element D. Okay, and then we're going to draw how the structure is loaded. Okay, so under axial stress, so axial stress over here is going to contribute in our stress X direction, right? It's going to contribute in our stress X direction. So over here you have all have minus Px over A. Minus Px over A. Minus Px over A. Minus Px over A. All of them are minus because the axial load is going at minus 2,500 pounds. So that's where what do I say? The maximum stress going to induce is going to be compression and not tension. It's because it's controlled by the axial stress of minus what? Px over A. Okay. Then you look at the next thing. Now you look at the shear, right? So the shear over here, right? The shear over here will be equal to TR over J. So all of them will have TR over J, right? All of them. The shear magnitude is all going to be the what? Same, because the radius, right? Element A, B, C, and D are on the outer radius. Okay, so it will be constant. Okay, then the next one is due to our what? Is due to our bending moment. Right? So the next one that we see is due to our bending moment. Okay, so a bending moment will be equal to mz over izz multiplied by y. So at point A, we are going to have positive, right, mz over iz, or mz multiplied by y, divided by izz. At point B, because it's going to be at a neutral axis, it's going to be what? 0. Right? Then at point C, is equal to minus mz multiplied by y divided by what? Izz. And then at point D, which is at the other end, because it's on the neutral axis, is equal to what? 0. Okay. So when that's the case, right, what you can see it down here. So anyone can tell me which element should we analyze? A, B, C, or D? Anyone, please.
C.
Yep, element C. We have done. So we have to be analyzed, right? Element C, right? So we realize that element C will be exposed to the maximum compressive normal stress. Okay. Again, I highlight maximum compression. If you don't know Tresca criteria, you can either investigate A or C. Okay, if you don't know Tresca, because you will go for A, because Eugene, you know, you look at the question, right? If you look at the question, based on over here, we are only given the what? The U point of tension. So I don't know anything about compression. Why should I bother? Yes or no? No, you should be bothered because in Tresca, the U in tension is equal to the U in what? Compression. As I said, a simple question like this, it really tests you whether you understand how to apply Tresca criteria. Okay. By the way, what are we trying to find down here? Oh, so we are sorry. We are going to find what is the minimum diameter of the what? Of the shaft. I repeat again, that is what we are trying to allocate. We're going to try to find the minimum diameter of the shaft. Okay. You know, sometimes when you do a long question like this, you don't know what you're trying to find. I got that problem before. Right. So now we know that we have to find what is going on element C. So now we're going to sketch what is going on at element C, at the shaft. Okay, we're going to sketch what is going to happen. So we're going to sketch at element C. Okay, at element C. So I'm going to view from the bottom now. Okay, so this is my X. And this is my Z. Okay, so this is the shaft. I do apologize. Okay, those elements should be located not there, but here. Okay, more like here. Do apologize for that. Okay, so now we look at the shaft. Right. So if we are staring at the bottom, right, we're at the bottom now. Right, this is our element at this point. Right, this is our element C. Okay, that is our element C. Okay, so this is our element C. And then because we are staring at the bottom, right, the torque in the X direction is flowing that way. So this is our 2,300 pound-feet. Okay. So for the shaft to feel the torque, one end has to be locked. So this end has to be locked. So how this element will deform, the element will be deforming this way. Okay. And then the element, right? So for the element to be deformed this way, the shear has to be in this direction, right? The pinching effect. Remember, I taught you guys how to pinch, right? And then we also have a load in the x direction. So this is our P in x. Okay. So in terms of the element, how does it look like now? So if you go over here, so now this is your Z, this is your X. So how the element, the stress state of the element will look like now will look like this. So we know that we have stress X value, right? And then we know that we have a shear going this way. So this is our shear XZ, okay, and which is equal to our shear ZX, right? So from here, we know that stress Z will be equal to what? 0. Okay, we know that stress Z will be equal to 0, but there's a shear Z. So now, how does that bother us? Once we construct all this, so what? Right? We ask ourselves, so what? Okay. So now, if we draw this in 3D element now, okay, if we draw this in 3D element, so in 3D element, now it will look like this. Okay, so in 3D element, so this is curve. Now let me draw the bottom because our shaft is at the bottom. We're analyzing the bottom. Let me draw the bottom. So at bottom, it will look like this. The element will look like this. Right? Right, there is the bottom. This is our element C. So we know that this will be our X. This will be our Y. And this will be our what? Z. So we know that over here, this is our stress in the X direction. Okay. And then we know the shear, right? So if we look at if we look at there, the shear will be flowing in this direction, right? So this is our shear in our X Z direction, which is equal to shear ZX, and then stress Z, which is in this direction, is equal to 0, and then from here, right? If I draw a point here, at the other end over here, this is our stress Y is equal to what? It's equal to 0. Okay, stress Y is equal to 0. The only way stress Y is going to have a magnitude, how can we induce a stress in the Y direction? One way is to submerge the entire structure into what? In water. Okay, so when you submerge your entire structure in water, you go deep enough, you are going to have stress Y a certain value. For now, it's in atmosphere. Okay, it's not going to be having any stress value. Okay, right. So from here, we can now sketch, right, how our roughly how our mole circle will look like. Okay, so let's sketch our mole circle. Okay, this I repeat again, this is just a sketch, and I'll tell you why we are sketching now. Why we are sketching? Because only after we sketch, okay, so this is only after we sketch, then we know which one to use. Is this stress max is equal to half of sigma max, or the shear stress maximum is equal to half the absolute value of the more normal stress maximum minus the normal stress minimum? Which one to use? Okay, so now you go back over here. So now you sketch. Okay, as I say, I'm just sketching. Right, so now we sketch. So you will have normal stress, and then you have shearing stress, right? And in 3D mole circle now, okay, you know that point. So if I'm going to label this, okay, we're going to label this. So this is your X, this is your Z, and your Y surface, the one below, Okay, so the surface below, right? The surface at the bottom is your y. Okay, so we know that at point y, you have nothing.